Flight engineers at the University of Central Florida are currently working to unlock the key to safe hypersonic travel. Elon Musk is known for pushing boundaries, but this time he's striving for something that could go beyond every limit we currently understand. Musk is developing a hypersonic jet that could entirely change air travel as we know it. This jet is so fast that it could complete the journey from Tokyo to Paris in just a little over an hour. If this becomes a reality, it would be a revolutionary change for the aviation industry, marking the beginning of a new era in global connectivity. Could this be the future of travel, or is it just another extravagant rumor? Stay with us as we delve into the details of Elon's groundbreaking hypersonic jet that challenges the limits of physics. The search for hypersonic jets is becoming more intense, and Musk has revealed the X-1, a hypersonic fighter jet unlike anything seen in the aerospace industry before. The X-1 is capable of reaching speeds of Mach 6, which is faster than 4,600 kilotons per hour. It also boasts cutting-edge technology that makes it nearly invisible. Its propulsion system is based on SpaceX's Merlin and Raptor engines, which enhance fuel efficiency by 30% compared to conventional jet engines. While the X-1 is primarily designed for military purposes, the advancements in hypersonic technology could eventually be applied to civilian aviation. Imagine passenger jets inspired by the X-1's design, able to make a 90-minute transatlantic flight a reality. However, it's not just about speed. Musk's entry into the hypersonic race has sparked intense competition, and the progress being made is nothing short of extraordinary. So, which other companies are stepping up to challenge Elon Musk? Read on to find out. Several companies are in the race to develop hypersonic technology, with some of the biggest players being Hermes, Straddle Launch, and Hypersonics. These companies are working tirelessly to create new propulsion systems and materials that can withstand the extreme conditions of hypersonic flight. Their goal is to push the boundaries of aviation and make hypersonic travel a practical reality. Musk's SpaceX has also entered the competition with the X-1 fighter jet, a military-hemmed hypersonic aircraft. The X-1 can reach speeds of up to 4,600 mph and is equipped with advanced features like radar camouflage technology. Although the X-1 is intended for military use, the technology developed could eventually benefit civilian aviation. The competition among these companies is driving significant innovation in the aerospace industry, and it's thrilling to think about where this could lead. The X-1 developed by SpaceX is an extraordinary piece of technology. This hypersonic fighter jet relies on propulsion systems derived from SpaceX's Merlin and Raptor engines, which are known for their efficiency. In fact, the X-1's engines are about 30% more fuel efficient than traditional jet engines. This efficiency is crucial for hypersonic flight. The X-1 also features radar camouflage, making it harder to detect. Although it's designed for military use, the advancements could eventually influence the development of civilian aircraft, demonstrating how military and civilian needs can overlap in the world of aerospace innovation. The potential uses for hypersonic technology are enormous. In commercial aviation, it could revolutionize air travel by drastically reducing travel times for long-distance flights. Imagine flying from New York to London in only 90 minutes. This would completely change the way we think about international travel. But the impact of hypersonic technology isn't limited to commercial flights. It could also have significant implications for national security, with military aircraft capable of reaching hypersonic speeds having a major edge in terms of both speed and stealth. This could be a game-changer for defense and combat. In the field of space exploration, the same propulsion systems and materials that make hypersonic flight possible could be used to enhance spacecraft. The possibilities for how these advancements could open up new frontiers in space exploration are incredibly exciting. Of course, developing hypersonic technology comes with its own set of challenges. One of the biggest obstacles is managing the extreme heat generated at such high speeds. At speeds above Mach 5, temperatures can exceed 1,800 DEGF, hot enough to melt most materials. Engineers need to develop new materials that can withstand these extreme conditions. Another challenge is designing propulsion systems that are efficient enough to support hypersonic flight over extended periods. Traditional jet engines aren't designed for these kinds of speeds, so new designs are essential. Environmental concerns are another consideration. Hypersonic flight could produce significant noise pollution and emissions, which would need to be addressed. Finally, there's the question of economic feasibility. While the technology may work, it must be affordable enough to make widespread use practical. These are significant challenges, but they are not insurmountable. Looking back at the history of high-speed aviation, the Concorde is a great example of what's possible. The Concorde was a supersonic passenger jet that flew at speeds of 1,354 mph, more than twice as fast as conventional commercial planes. It could travel from New York to London in under 3 hours, which was revolutionary at the time. The Concorde entered service in 1976 and remained in operation for 27 years, symbolizing luxury travel and cutting-edge technology. However, it never reached hypersonic speeds, which start at Mach 5. Even so, the Concorde proved that supersonic passenger travel was achievable despite its limitations. It was retired in 2003, marking the end of an era. Its final commercial flight took place on October 24, 2003, and just a few weeks later, the Concorde set a speed record by flying from New York to Seattle in under 4 hours. Although the Concorde was retired, its legacy continues to inspire the development of faster, more efficient aircraft. However, the Concorde did face several challenges. One of the biggest issues was the noise generated by the sonic boom during supersonic flight. As a result, the Concorde was restricted in where it could fly at top speed, mainly operating on transatlantic routes over the ocean. There were also environmental concerns regarding fuel consumption, emissions, and the high cost of flying on the Concorde, which limited its accessibility. These factors contributed to its retirement. Still, the Concorde's impact on aviation is still felt today and paved the way for future advances in high-speed flight. Now, companies like Hermes are pushing the boundaries even further. Hermes, a startup founded in 2018, is focused on developing hypersonic passenger aircraft. The company aims to exceed Mach 5 speeds, faster than the Concorde, with the ultimate goal of reducing transatlantic travel time to just 90 minutes. Hermes is drawing inspiration from both aviation history and recent advancements in space exploration. Their approach is innovative and seeks to overcome the technological and market challenges of hypersonic flight. One of their key projects is the Quarter Horse, an unmanned prototype aircraft designed to break speed records and validate hypersonic technologies. The Quarter Horse will serve as a stepping stone toward developing passenger-capable hypersonic planes. It is designed to surpass the speed of the Lockheed SR-71 Blackbird, one of the fastest aircraft ever built. One of the most exciting aspects of Hermes' plan is the Chimera engine, which combines elements from turbojet, ramjet, and scramjet engines into one system. Turbojets are great for taking off and reaching speeds of around Mach 2, but they struggle at higher speeds. Once the aircraft reaches higher speeds, the Chimera engine switches to ramjet mode, which performs better at speeds above Mach 5. This innovative design allows the engine to handle everything from takeoff to hypersonic cruising without any issues. Hermes initially used existing turbojet engines to avoid the high costs and time of developing a new engine from scratch. However, they made a major breakthrough in November 2022 when they successfully tested the transition from turbojet to ramjet mode. A crucial step, as the ability to switch modes smoothly is vital for hypersonic flight. Their second prototype, Chimera 2, uses a more powerful Pratt & Whitney F100 engine, which is used in fighter jets like the F-15 and F-16. This engine has accumulated over 30 million service hours, proving its reliability. By May 2024, Hermes began testing a new cooling system designed to handle the extreme heat generated during hypersonic. Heat management is one of the largest obstacles to making hypersonic travel a reality, and Hermes' work on this system is crucial. What stands out about Hermes' progress is how quickly and cost-effectively they have moved forward. They developed and tested the first Chimera engine in just 21 months for only $18 million, a fraction of the cost of traditional aerospace projects. However, developing the Chimera engine hasn't been without its challenges, particularly with managing the heat generated at hypersonic speeds. Hermes is working on advanced cooling systems, such as pre-coolers, to prevent the engine from overheating. Another challenge is integrating turbojet, ramjet, and scramjet components into one engine. These engines operate very differently, and combining them into a single system is a complex engineering feat that requires breakthroughs in thermodynamics, material science, and fluid dynamics. If Hermes succeeds in developing the Chimera engine, it could revolutionize air travel, enabling flights anywhere in the world in just a few hours. The technology could also have applications in other industries, such as shipping and space exploration. The quarter-horse project, a key part of Hermes' development plan, is testing the Chimera engine in real-world conditions. The first prototype, Mark 0, was a ground test vehicle designed to ensure all systems functioned correctly before flight. By early 2024, Mark 0 had completed a series of successful tests, paving the way for flight trials. The next versions, Mark 1 and Mark 2, will focus on flight tests, with Mark 1 aiming to achieve full hypersonic capabilities. Hermes' approach is notable for its focus on affordability and efficiency. While traditional aerospace projects are often expensive and time-consuming, Hermes is using off-the-shelf components and focusing on incremental progress. This approach has allowed them to make rapid progress, completing the first Chimera engine in less than 2 years at a fraction of the cost of traditional projects. Ultimately, the potential impact of the Chimera engine is immense. If successful, it could make long-distance air travel much faster and more efficient, and it could lead to advancements in cargo delivery, space exploration, and even military operations. The possibilities are endless, and Hermes is at the cutting edge of this exciting new era in aviation. Stay tuned for more.